Okay, so today we're going to continue on with our trig derivatives, good stuff, and we're going to look at applications of the trig derivatives. Remember, it's not always just about finding the derivative, it's about using the derivative. Good stuff. Alright, so first, I want you to try and find the 105th derivative of the sine of x. Yeah, that's what I said. So, I'll give you a hint. Once you start to find, the second derivative, and the third derivative, and the fourth derivative, and so on, you might start to notice a pattern. So, try to figure that pattern out. Pause the video, find the 105th derivative, unpause when you're ready to check your work. Okay, so we should get that the 105th derivative of the sine of x is just the same thing as the first derivative of the sine of x, which is cosine of x. Now, why is that? You might have gotten lucky and guessed, maybe you found the pattern. Well, the pattern is that the first derivative is cosine of x, the second derivative is negative sine of x, the third derivative is negative cosine of x, and then the fourth derivative goes back to being the sine of x. So every four derivatives you go right back to being at the original. So then the fifth derivative would be the cosine of x, and so on. Sixth derivative would be negative sine of x, seventh derivative negative cosine of x. Now still, with the 105th, well, you don't want to have to count out every single one of those and figure it out. So remember back when you first learned about I and the powers of I and how those repeat every fourth power. Well, you can use kind of the same trick that I showed you back there, where take this number, in this case 105, and divide it by 4, because every fourth derivative it's going to repeat. So what's 105 divided by 4? Well, it's 26.25, or you could say 26 and 1/4. So the 26, this is just telling me how many times it goes into 4 evenly. So I can ignore that, and I see that I'm left with 1/4. So the 1 is what tells me this is the same thing as the first derivative. Had this been, say, 26.5, then I could think of this as, well, 1/2 or 2/4. So it would be the same thing as the second derivative. If you get 3/4, it would be the same thing as the third derivative. And like I said, if it divides evenly into 4, then it is just the original function. So this is our pattern with sine of x. So that's how we can evaluate higher order derivatives of the sine of x. You can also find a pattern for that with cosine of x. It's going to be very similar. Alright, moving on to some applications. So I want you to write the equation of the tangent line at x equals pi/4 of the function f of x equals x times tangent of x. I want you to write it in slope-intercept form. So pause the video, unpause when you're ready to check your work. Okay, so we should end up with y equals the quantity 1 plus pi halves times x minus pi squared over 8. Lovely line, right? How do we come up with that? Well, first I want to figure out, since I know x equals pi/4, what is y equals there? What does y equal there? I need to find the point. So first just plug in pi/4 to the original function. F of pi/4 is pi/4 times tangent of pi/4. The tangent of pi/4 is 1, so this is just pi/4. So you're actually looking at the point pi/4, pi/4. Okay, now we need to find the derivative so that we can find the slope of the tangent line. So f prime of x is, we have to use the product rule, derivative of the first times the second plus the first times the derivative of the second. Now once I know the derivative, now I need to find what is f prime of pi/4. So plug in pi/4, tangent of pi/4 plus pi/4 times the secant of pi/4 quantity squared. Tangent of pi/4 is 1. The secant of pi/4 is root 2. When I square root 2, it becomes 2. 2 times pi/4 is pi halves. So f prime of pi/4 is 1 plus pi halves. We do not want to type that into our calculator. We like exact values. Now we need to find the y-intercept, since we want our answer in slope-intercept form. So if I know y equals mx plus b, y is pi/4, x is pi/4, m is 1 plus pi halves. I'm solving for b. distribute the pi fourths, I get pi fourths equals pi fourths plus pi squared eighths plus b. The pi fourths and the pi fourths are going to cancel. I'm going to subtract that from both sides. And then we end up with b is negative pi squared eighths. So when we rewrite our equation, y equals 1 plus pi halves x minus pi squared eighths. Next, given f of x equals cosine cubed of x, I want you to find the critical values for x on the interval 0 to 2 pi, including 0, not including 2 pi. Notice I'm just asking you to find the critical values. You're not determining if they are maximums or minimums. They're just critical values. Pause the video. Unpause when you're ready to check your work. Okay, so we should end up with x equals 0, x equals pi halves, and x equals 3 pi halves are our critical values. We get that by first finding the derivative of the function. So f prime of x is 3 times cosine squared of x times the derivative of the cosine of x, which is negative sine of x. So we had to use our chain rule there. Set the derivative equal to 0, and since this is all multiplication, I can just set each product equal to 0 from our zero product property. So 0 equals 3 cosine squared of x, divide by 3, take the square root, and I get cosine of x equals 0. 0 equals negative sine of x, divide by negative 1, so sine of x equals 0. Where does sine of x equals 0? Sine of x equals 0 at 0 and pi. Where does cosine of x equals 0? Cosine of x equals 0 when x is pi halves and 3 pi halves. Now, take it a step further, find the max and min for f of x equals 1 plus sine of 2 pi times t minus 60 over 365 when t is greater than 0. Pause the video, find the maximum and minimum, unpause when you're ready to check your work. Alright, so we should get a max is going to occur at 151.25 plus 365n, where n is greater than 0. And then we should get a min is going to occur at 333.7, t equals 333.75 plus 365n, where n is greater than 0. And it's an n is an integer greater than 0. We're assuming it's an integer. I'm just saying it's greater than 0 because we're talking about t being greater than 0 as well. Or we were only looking when t is greater than 0. So how do we come up with all this? Well, first, recognize this is just a trig function. Specifically, it's sine. Notice this plus 1 is going to be a vertical shift of 1. It has an amplitude of 1. And then we could find the period and horizontal shift if we want. That's not as important. The big thing is recognizing we have a vertical shift of 1 and an amplitude of 1. Other than that, it's just a sine function. So find the derivative. F prime of x is the cosine of 2 pi times t minus 60 over 365 times the derivative of the inside, which is just 2 pi over 365. Set the derivative equal to 0 to find maximums and minimums. So set it equal to 0. First, I can just divide everything by 2 pi over 365 to get rid of that. So now, essentially what I'm doing is I'm asking myself, where does cosine of 2 pi times t minus 60 over 365 equal 0? A simpler way to say that is, where does cosine equal 0? First, I'm just going to find the values between 0 and 2 pi. So cosine equals 0 at pi halves and at 3 pi halves. So I can set 2 pi times t minus 60 over 365 to pi halves plus 2 pi n when n is greater than 0, and 2 pi times t minus 60 over 365 to 3 pi halves plus 2 pi n when n is greater than 0. Again, the only reason why I have to worry about, or why I'm writing n is greater than 0, is because that was stated in the problem that t needs to be greater than 0. So in order for t to be greater than 0, in this case n has to be greater than 0, because normally I say n just represents all integers. Now I'm saying it represents all positive integers. So now solve this for t. So I multiply everything by 365, divide everything by 2 pi, and then add 60. So that's how I end up with t equals 151.25 plus 365n. Same thing here. Solve for t, multiply by 365, divide by 2 pi, add 60. So that's how I get t equals 333.75 plus 365n. Now, notice that I didn't do the increasing-decreasing chart or the second derivative test. Why is that? Well, that's because I understand the sine function. Think about your basic sine function, which is what we're trying to find the maximum and minimum at, and since the critical values that I found were pi halves and 3 pi halves, I know sine is a maximum at pi halves. From my unit circle, sine equals 1 at pi halves, or if I think about the normal graph of a standard sine function, sine of x, it's going to be a maximum at pi halves. So the t value that I found from the critical value of pi halves is going to be my maximum. Same thing is true with the minimum. Sine is a minimum at 3 pi halves. So as long as I recognize that, then I know this is going to be the minimum value. You can also use the second derivative test or an increasing and decreasing chart for the first derivative to show this as well. Okay, so now you want to find if you have a triangle. So the fact that it's a triangle is restricting us. Find the maximum area of the triangle. Given this is theta, that's 3, and that's 3. I will give you a hint. You're going to want to use one of the area formulas that we learned back when we were doing law of sines and law of cosines, and it is not the Heron's area formula, it is the other area formula. Pause the video, unpause when you're ready to check your work. Okay, so here we should end up with when theta is pi halves, we get the maximum area. How do we come up with that? Well, first, the area equation that I was referring to was area equals 1/2 AB sine theta in this case. Recognize that theta has to be between 0 and pi. The problem doesn't state that, but in order for this to be a triangle, that has to be true. So this is a restriction that I have on theta. Well, A in this case is 3, B in this case is 3, so area is 9/2 sine theta. What is the first derivative? A prime is 9/2 cosine theta. Find your critical values between 0 and pi. So set this equal to 0, divide by 9/2, cosine of theta equals 0 at pi halves when I'm restricted to 0 and pi. So then I used the second derivative test. So the second derivative is negative 9/2 sine theta. A double prime of pi halves is negative 9/2 sine of pi halves, which is negative 9/2. The thing that I care about is that it's negative, which means that this is a maximum, because that is concave down. So since a prime of pi halves equals 0 and a double prime of pi halves is less than 0, at theta equals pi halves is a relative max. And we actually probably should say at theta equals pi halves because we want it in the specific context of the problem. That gives us the maximum area in this case. Okay, so we want to make sure now, we've been just kind of going through finding derivatives of trig functions, that we don't lose sight of what the derivative actually represents. It's the slope of a tangent line. It allows us to maximize or find maximums and minimums of things because we understand that if a slope of a tangent line equals 0, that's going to be a maximum or a minimum. So we don't want to lose sight of that.